So I'm Brian Farling with Jones Studio. And the Mariposa Land Port of Entry was a 200,000+ square foot project, 54 acres. And in a very simple way, it's all about processing people and goods across the border with a commitment to making it a human experience, making it something that has some dignity to it. And what we were committed to do was to make that happen. And we did it by infusing nature, by making it an oasis, by capturing rainwater and making as many garden spaces on the project as we could. Sort of the essential elements of the architecture. You can boil it down to a section. And in that section you have a garden, you have an interior space that's kind of shaped to open up to the garden, and then you have a wall that is the secure wall, which is a bullet-resistant wall. So this is tilt concrete with thermal mass so that it has a high insulation characteristic. The interior space has a glazed wall and then a Hunter Douglas ceiling, where the lines of that ceiling sort of take your eye out to the garden space.
It's a Hunter Douglas V200 baffle series, which is a simple blade on a carrier that is we can either make it flexible for access or we can keep it rigid.
The linear baffle system, the V baffles, were perforated. They were a custom design, come out of the Netherlands with Hunter Douglas's plant over there overseas.
We were involved and we were very appreciative of this very early on in the process. And I think for manufacturers and vendors and contractors to be involved as early on as possible makes a project go substantially better. And with Hensel Phelps, who's a fabulous, CM, to get those guys involved, and Jones Studio involved, and TP Acoustics involved, and Hunter Douglas involved, it just made that process so much smoother, which is important.
One thing that we partnered with Jones on was an exterior application or a modified application, which we were able to utilize a unistrut system and then come off of welded points of the building with aircraft cable and decorative hardware, and suspend the same interior system outside, which could be sustain wind and weather and whatnot.
The interesting story is we spent 5 years working with Jones Studio down there, the Mariposa Land Port of Entry. Since then, I've gone to other ports of entry and dealing with the various exterior systems that CBP requires for bullet resistant and safety. What comes to mind is as we go to deal with the studs and all the myriad of possibilities that you can use to put those systems together, there's always kind of holes, there's special considerations of how studs come together. When I go back and think about Mariposa in terms of the tilt panels and the construction there, it was an exterior wall and it was bullet resistant from end to end.
The need for exposed concrete on both inside and outside of the wall system, and with this being a conditioned space, insulating those walls is obviously important and meets the energy codes and the design challenges. And with thermal mass, it's a perfect fit. The connector that was used on the Mariposa project had 42,000 strands of fiberglass throughout the connector itself. And at the end of the day, when we make the connector, you're correct. It's strong enough to handle the loads and to pick the panels up and then remain in service for long periods of time. But yeah, the connector itself is non-conductive, non-corrosive, alkaline resistant, twice the strength of steel, very, very strong. It acts as a tension tie, so it's holding that structural layer of concrete together, keeping the insulation within the wall, and then suspending that architectural fascia.
When you look at the pictures of the finished product, there's pathways of footprints, and it was, from a contractor side, very interesting to look at that right off. Like, holy cow, how in the world are we going to go get somebody to walk across the concrete and make it look just like this as it's shown in the architectural renderings? And we first talked about, wow, it can't be that bad, just walk in circles. And how's that going to go actually embed in the concrete? Plus, when you look at it, you're going to put your architectural finish down first, so you can't really walk upside down on the bottom of concrete. The impossibilities of it all. So the specifications were originally a heavy sandblast texture. We went out right off and gave it a try. And it was a credit, I think, to our superintendent to realize, hey, this doesn't look like a footprint. It looks like a shadow of a footprint maybe. And so we brought Joan Studio in to figure out how are we going to go do this, because the sandblast effect, while it's there, it doesn't show the detail that we recognized in the plans. And so we went through a few iterations, and it finally came to cutting the sole off of the shoe and saying, hey, this can be cast in. We've done it with letters for universities and that type of thing. Why can't we do it with a shoe? And so we ended up ordering boxes and boxes of rubber-soled shoes. And then it was a team effort to finalize the layouts that were going to go on the walls, cut out each shoe print off the paper so we could glue it on in the right spot. And then with those as molds, lay down on a casting bed. It was easy after that. And the proof is in the pudding. It looks great. You go out there, the pictures that you see throughout this presentation, you can see the shadows and you pick up, hey, there's somebody really going somewhere through the port and catching up to each other. It was a lot of fun. And it's one of those things you look back on in terms of career that, hey, that's pretty cool to see how all this comes together, where on day one, you're like, I'm not quite sure how this is going to happen, but team effort brings it all together, and a lot of fun to go do.